All right, today we're going to be looking at section 5.2, exponential functions and their graphs. We have two objectives. We want to graph exponential equations and exponential functions, and then we're going to solve some problems involving exponential functions and their graphs. So we start out with a scenario that kind of show you two pictures of exponential graphs. We have the definition of what an exponential function is. So it's a function of the form f of x equals a to the x power, and they let us know x is a real number. A, whatever that number is, has to be greater than 0, but it cannot be equal to 1. And a is called the base. Base is required to be positive in order to avoid imaginary numbers. You have some examples here. You have 2 to the x power, 1/2 to the x power, and you got a rational number 3.57 to the x power. So they give you several different examples to view. They show you a table giving you some x values, plugging those in and getting some ordered pairs. Usually when you make a few ordered pairs, you can get a general shape of what the graph looks like. One graph, which we'll talk about it, and it tells you it doesn't touch the x-axis. It kind of curves and gets closer and closer. One graph is increasing as we go left to right. We'll talk about that as being called growth, and one is decreasing when the value of a is between 0 and 1, and that will be decreasing or decay, and they're letting you know some of that. We have a horizontal asymptote of 0. Here are some properties that they let you know. A is greater than 0, not equal to 1. It's continuous. It's a one-to-one graph. Domain is negative infinity to positive infinity. The range is 0 to infinity. If a is greater than 1, it's going to be increasing. It's decreasing if we were between 0 and 1, so whatever that number is that's attached to our exponent. Horizontal asymptote is the x-axis, and the y-intercept is 0, 1. That's the standard basic graph. In our homework, we are going to be doing some describing how the graph can be obtained from the original graph, like if it's shifted right to up, down. And so let me go back over the transformations that we would have seen in chapter 2, or at least the document that we have in our online course. So in our online course, Blackboard homework videos, chapter 2 is where we have those parent functions. So we have two of them. We have parent functions plus and just regular parent functions. I'm going to go to parent functions plus. This is where we talked about transformations, just to kind of show you or review this concept again. So you have most of the parent functions. Here's the exponential function. Here's some of those properties that they were talking about. If you scroll all the way down past the trig, you will get to graphing tips. And so these are like the basic form and transformations. So notice the k is outside, not attached with anything, not in parentheses. That's going to give you a vertical translation, shifted up or down. The h, which is usually in connection with the x, that's going to move it left or right. And this, you have to note, it says a positive moves it right. The formula has a negative, so when you plug a positive into this formula, it's going to appear negative. So I just tell my students, do the opposite of what you see when you're looking at the numbers that are in some kind of grouping symbol or with the x. If you have your a value, which is out front, your multiple, that is going to stretch it, vertical stretch or compression. We just say dilation, vertical dilation. And then you also have the b, which is also a factor on the x, is kind of in that grouping symbol. That is going to do a horizontal dilation, horizontal stretch or compression. Then you have, if the a is negative, it's going to flip it across the, it says rotation about the x-axis, is going to flip it across the y. So you have a positive x this is a positive y value going to a negative. It's going to reflect across the x-axis. The negative b would cause it to reflect across the y-axis. So those are the main transformations you want to be familiar with. We're going to see those throughout this section. So that document is in our Blackboard. And so you can kind of see some examples where they're plugging in different values, negative values, cause the graph to flip or reflect across the axis. This 5 shifts it up. Then the applications are going to be dealing with compound interest. So they give you some example. They tell you 10,000, 6.5 interest compounded semi-annually. So learning those verbs semi-annually twice a year. So that's how they get n equals 2. And then they plug it into this compound interest formula. And you will need a calculator to compute those. They talk about the number e. Exponential. It's roughly 2.71, but we have that value on our calculator. E helps us with this exponential growth. Here's the value of E. And we'll just go over a few more examples showing some graphs in ordered pairs, making tables, plotting points, seeing the shape. It's the same as the exponential graphs that we've seen. E does the same shape. Okay, exponential growth or decay, depending on if that value is positive or negative, or if it flips across the x or y axis. And that'll be it. That's just a summary. With this, we're going to jump into My Math Lab and do some problems. And again, you can kind of see it says transformations, review section 2.5.